Bismillahir Rahmanir Rahim. Today, inshallah, we'll talk about solving some examples in process fermentation and how to solve it. This question is saying that fill the blanks. The following two figures show devices to measure, and then he gave me a space here to find the measurement of another space. The first figure uses the one, and the second one uses the space method. Now you see here there's two devices. One of them, it has a mirror here, and the mirror here, it is built above a pelleter cooling layer, and there is a heating sinks after lower than it, and here there is a light emitting diode which will emit the light beams on the surface of the mirror and will be received by this phototransistor. The reflection here will be measured by this phototransistor, and the viewport here will see the reflection angle here, how much is it. And here there is temperature sensor in order to compare the temperature of this mirror. It will be cooled down in order to make a condensation of water drops on the surface of this mirror. So here we can say these devices are used to measure dew point, because here there is the drop of waters. To find what? To find the measurement of what? Humidity. This is the purpose of finding the dew point. We can understand the humidity. That's why I'm measuring the temperature here sensor, to compare it to the draw point and see what will be the humidity ratio after that, or relative humidity after that. The first figure uses the automated optical sensor as I explained. The second one here, if you see, there is a grid here called grid, and another one here, and there is here inert surface, polished inert surface. This surface, it's exposed to the air, and if there is a drop of water, will absorb this drop of water inside it. And we see here the wire is here connected between these two separate grid, and this surface will connect between them. If the resistance very high, that means it is very dry. But if the resistance becomes lower and lower, mean the conductivity more, that means more water drops absorbed by this surface, which are engaged on connecting the currents between this wire. So here the method here is using the surface conductivity method. Now for this question, measurement of viscosity are carried out based on the three phenomena. What are these three phenomena? Have been given to my student. There are three phenomena are mentioned or explained in these sources to measure the viscosity. The measurement of viscosity can be measured by this method. I write it in order to save the time. Either by the differential pressure method, using the flow of the liquid or the fluid through the capillary tube. The second method, the friction force effect measurement by dragging the falling ball in a cylinder, and see the effect of friction, of course high friction mean high viscosity, on delaying the falling of the pole speed. Also the famous method, also the rotation or eccentric cylinders, two eccentric cylinders, one of them is in the center of the other, and the liquid will be filled between the surface between these two cylinders, and the tested fluid will connect or transmit the speed or rotation between them, and depend on the level of the viscosity and the measurement of viscosity, the speed of transferring this speed between them will be more. This is the three methods of measuring or phenomena to measure the viscosity, either by friction or differential pressure, or by testing the affecting the speed on the layers of the liquids. Type another question here. You say A worker in a dairy plant has a container used to measure the density of milk and its volume is 1.5 meter cube. He knows that the pure milk density should be between 25 QVNU and 35 QVNU. These are special density units. If the density is more than that range, it means there is no purity in the milk, and if it is less than that, it means there is more water mixed with it. He found that the measured mass was 1680 kilogram for this tanker. Was this amount of milk pure or not? We need to check it. If there is non-purity or more water, explain how can you find the mass of this part. Assume that this part has the same volume of the container to make the calculation easy. طيب, now we'll answer the first question. Was it pure or not? I cannot decide until I calculate the density for this container or for this milk inside this container. QVNU here, it is a special unit used in the dairy plants for explaining the density units, and there is a relationship between the specific gravity and the QVNU units. The relationship between them, it's saying that, so in this case I can say I want to find the SG itself, which is equal convenient units divided by 1000 plus 1. Yeah. So I can find my SG equal, first we will test the 25 as he mentioned here. He say 25 convenient. So that means my SG equal this 25 divided by 1000 plus 1, which is equal 1.025 as SG. 35 SG equal 35 divided plus 1, which is equal 0.035, and it is given that the reference water density is 997 kilogram per meter cube at 25 degree Celsius. So that means my this 1.025 SG, it is really talk about row of milk over the row of reference material. Now this one might mean 1.25 multiply 997 kg, and we know that the specific gravity does not have units, only the multiply it by the reference density to give us the density of the milk. This one for 120, and the same thing will be happened for we want to find our given values, which is our milk here. let's find its density 1680 over 1.5. It gives kilogram per meter cube, which is mean here it is not pure. It is not pure milk because density is more than 35. Convenient. طيب. And how can you find the mass of these non-pure part? And he say assume that this non-pure part or this addition part or this additional mass above this milk, it has the same volume of the container in order to make the calculation easier for us. So I know that my maximum density for the milk should be 1031.89. Simply we'll just find the density of this 1031 mass of milk, and should be pure maximum pure milk one thousand 301895 multiply by 1.5 meter cube, 1547.842 or 3 kilogram. Now just mass of non-pure equal the mass of this pure milk subtracted from the mass of the total. One 132.157 kilogram. This is the mass of the non-pure parts.